Okay, so we have added prepend, append. So what we're gonna do next, maybe one interesting thing to do is to actually find an element inside the list. So if it would exist, we would return that element, and if not, maybe we can return null to show that this element does not exist. So let's do actually that. Creating a new test here. This time I'm not going to be copy pasting anything because we're actually doing something completely different than adding elements. We're actually finding. So find element does not exist. So when element does not exist, returns null. We're actually describing what we need the test to do here, and this is what we're actually doing. So we need to actually find, nope, this is not what I want to do. I want to find, let's say, element 0, nothing appended or prepended in the list, so this is basically going to be returning something that we actually want to assert. We have an assert null special method in assert static class to actually, instead of actually asserting equals to null, we can actually assert null and actually get rid of that here. So we have a compiler error. Let's create a member function, find. Here I'm going to do helps me, thank you. We'll create, yes, it returns a t, that's right. I'm going to be adding it as an optional since this can return null. And to make that test pass, what we basically need to do is we make it return null. So if my hypothesis is correct, we should have a green test. Awesome. Let's create a different test. Find element exists. When element exists, we can actually return its element. So we actually be adding an append 0, and we're going to be looking for 0. So what we actually need to do is we need to, this would be the value that we need to return. So this is in the head, we're looking for the head, so this is what I'm going to be asserting as assert equals that the test list head dot value equals to what we actually found. No, basically we can actually check without the value. We need to find the actual element. So let's keep it as a head. We need to find 0. We want it to be the head because this is the only element in the list right now. And let's see. Yep, this fails because we're always returning null, and we basically need to return the head. Now, the simplest thing to do is make it return the head. What's the problem here? It needs to return a node. Oh yeah, this is actually my bad. We need to actually return my node and not just the value. So we're gonna be returning my node here. Let's run the test again. And now it passes. Why? Because we're actually searching, we need to have it as a null. We return the head, but this is always null. So in a sense, this passes by accident here. We have a by accident test. We're still having green all across the board, but of course, this is not to make us worried because we haven't even finished testing. This obviously doesn't work as it should. Now, to make it fail, what we basically need to do, let's append the second element here. We can append 1, and now we're going to be finding 1. And what we need to do, basically we need to keep that assertion here and make a second one. So we need to find 1, which is obviously going to be the next value of the head. Now let's run this. Yep, now we have a failing test, and obviously we're expecting a different node, that this is the pointer of the node. We don't actually understand exactly the value, but we don't care. We know why it happens. We're always setting the head. Now we can swap that and return the next, but this will simply swap the mistake. Now this assertion is actually being satisfied, but now the first assertion is not, which basically is a dead end. We can't keep going ad hoc here. We're actually going to have to put some thought into the algorithm. So let's do just that. In case the head is null, we should always return null. So basically, if the value in the head is null, there's no way we can find any element, so maybe I'm thinking to start doing it like that. So if head is null, we can actually return null. Something like that. Else, now this is the first algorithm, the first idea of the algorithm. Of course, we can actually make it better later in the refactoring stage, but bear with me, I'm going to be going slow. I also need to return something because the compiler will complain. Okay, let's return null so as to make it pass for now. And then if the head is not null, we basically need to traverse the list in some way until we find the element. And if we traverse it without finding the element, basically we're going to have to return null. This is what I'm thinking. Now we had traversed the list a little bit earlier here in the append method, so maybe I'm going to have to steal those line of code here, so it's basically going to be the same. So let's keep the current node as the head. While we have a next node to go to, we have to actually check whether the next node is the one that we're looking for. So maybe create an if statement. If the current node dot next dot value equals to the value, and we don't need to actually save operator here because we have the Kotlin smart cast. So if the value is here, we can actually return the current node dot next, because this is the value that we're looking for. It satisfies the case and we actually return it. And then after doing that, we can actually move on to the next node. Let's think about it a little bit. Now, if nothing happens here, this while loop will finish. We wouldn't have found the proper node, which will basically delegate the return statement over here, actually returning null. Looks good to me. Let's run the test, but of course we can't be sure. Maybe we have an error, and we do. We're expecting to have a node, but this is actually null. Now this is very interesting. Why did that happen? Let's see. Let's see which fails first. Let's find the first one and rerun the test, because I cannot actually understand what the fail is. Okay, we're failing on the first one. We're appending 0 and we're actually finding 0. And of course this is right, because if the head is null, we're returning null. But if the head is what we're looking for in the current node, we actually never check about that. We immediately go to the second one. We have to also take the case that the head is the one that we're looking for. So maybe we can actually refactor, let's uncomment that here, maybe we can actually refactor the first statement. Instead of having it being null, why don't we check that the head.value is the value that we're looking for. Let's try that. Let's try to see where this goes. Now, if this is the proper one, let's return the head. Now, we're returning the head if the head's value is the one that we're looking for. Otherwise, we go about traversing the list. Yes, this is correct. And if nothing of those happens, then we're actually going to be returning null. Let's run that again. It looks a little bit better, but we can leave the test tell us what happens, and yes, we have a green check, which means that now the algorithm works a little bit better. But in case you don't feel very comfortable yet, let's do it a little bit more. Let's add one more element. Let's add the 2, and I'm going to be actually looking for the next of the next to be the 2, element 2. Let's run that. Yep, we're basically confident now that no matter what the list looks like, we're actually going to be always finding the proper element. And of course, just as a sanity check, let's see if our coverage is still 100% like it should be. And I can already see that we have 100% here. Look at that. This looks very beautiful. We have actually tested our new linked list class to the full. Nice, we like that. So, what should we do next? Maybe what we need to do is to actually create a remove method, because we have actually found an element, we have actually appended and prepended an element, but what we haven't done yet is to remove an element. So we'll take it slow. This could be the most challenging of the tasks, but if we go with the test-driven way, we will slowly but surely reach a solution. So as always, we're going to begin writing a test. So what's the simplest test that we can do in a list when we have to remove an element? Maybe remove the head. So let's try to write a new test. So this would be remove head when list is empty. So returns no, and basically we'll do nothing. So we have an empty list, so let's go test list, and we're going to remove. I was actually looking for the autocomplete there, which obviously will never happen because we haven't implemented it. So remove 0, and we want to assert that this is null, so assert null basically. Now we have to actually implement the remove method. Alright, this is a value, and as always we're going to be returning an nullable value there. So we need it to be null, so why not go with the easiest way? We're going to return null, because this is what needs to happen in order to get a green test now. Let's see. Perfect. Easy test. Let's go to the second one. Let's go to remove head when list is not empty. Returns head. So what we need to do is we need to return the head and then make head return, make the next node of the current head be the new head. Returns head, and new head is previous second element. Again, not the best name I've ever given, but the idea is if we have a head, we have to remove it, but now the pointer of the head needs to point to the second element, the one that the previous head was pointing at. It's pretty clear. So to do that, let's set up our list. So let's go with a test list, append 0 and append 1. So what we need to do is we need to remove test list, remove, let's say 0. So by removing 0, we can actually assert equals, let's put it in a variable, element removed. So element removed should be the head, which will actually need to be in a val also. So let's keep the head test list. Head is the head at that point, so the element removed should be the head. And after doing that, we need to also assert equals that it's 0, it's 1 when we try to take the new head. So test list dot head dot value should be 1, because what we basically do, we removed 0, there it goes. By the time we remove 0, we want that element to be the previous head. This looks a little bit like we did with the find method. When we find an element, we took the head, we wanted to find 0, and we're expecting it to be it. In this case, we did it in 2 different steps, which we basically could have done differently. Maybe we could have done that inline. Let's do that inline, by the way. Yes, so we're asserting that if we remove the first element, which is 0, then it's going to be head. Good. And then we're also expecting that head is the value of the new head is actually 1. So let's run this test. It's a little bit weird to actually visualize, but By now, I think we have gotten a little bit more comfortable with the lists, so I think it should be pretty easier by now. Of course, it's gonna return, we have a problem. It's expecting to have an actual node here, but we're actually returning null, which is basically what we're doing here. So maybe right now we need to start thinking about how to do that. So when we remove the value from when we remove head, what we basically need to do is we're going to have to do the following. We need to actually return the head, but in order to return head, we need to actually, what's the problem here? Yeah, of course, we need to get this should be my node. We had the same issue before. So now we're returning head, but before we return that head, we need to have it removed. So maybe before we do that, we need to create a value. So let's create a variable, basically a constant that shows that current head, which is the head, this is what should be returned here. And then what we also need to do is the new head should point to the next value of the current head. Does that make sense? And then we should return the current head. So what we're basically doing, we're returning the current head, and we're also making the head of the list point to the next value. Seems good. Let's try to run this test again. And yes, we have a green check here, because what basically happens, we're expecting it to be null. Of course, it's going to be null because head in this case would be null, and we're returning it. Nothing would change here. Null will point to another null. So this test is fine. This test is fine. So basically, we have successfully removed the head. But let's get it one step further, because right now we're removing the head. I guess it's high time we removed any element that we possibly can have. So let's make it a little bit more generic. Remove element, let's rename that. Remove element when list is not empty. Yes. It returns head, and the new head, it returns the element. So this should be named return element, and removes element from list. Basically, we don't want that element to happen again. So let's use that remove function, of course, here. Let's append 3 nodes in the list, and we're basically going to try to remove element in the second position, so that we then have a 0 and a 2. So let's remove those assertions for a little while. What we have to do is we need to remove the second element. So assert that it would be 1 when we try to, no, it should be the test list dot head dot next when we try to remove element in position 1. So what we're trying to do now is we're going to assert that the next value of head is going to be the one that we have when we remove 1. But once we remove 1, the next value of head should be 2. So this is a little bit dangerous to do. Basically, not just dangerous, but it will not work. So we need to introduce a variable. So current second element, which is basically this one, and this is what we're going to assert that. So basically, we need to have that as it is, and we also need to assert that. Let's also create a different value here, that is current third element, which is .next, so we can have the current third element. And we also need to assert that the current third element is .value let's say current third element is the one that we can find if we start looking for test list dot head dot next. So after doing this removing here, we need to assert that the second element from head is now the current third element. So let's maybe name this a previous third element before removing third element. Again, I don't like this name so much, but it will work for now. Before removal should be much better actually. So let's refactor that a little bit. Before removal, third element. So let's see what happens if we run those tests. Of course, I'm not expecting it to work because we're actually not even taking into consideration what the value is here. So now maybe we start to have to think a little bit about that, because right now we only played in an ad hoc way, removing the head, but we obviously need to do something a little bit clever. We need to find the element first of all. So this reminds us a little bit of the find method that we had written, because we need to actually locate where that element that we pass as a value here is. So maybe try to use something from the traversing mechanism. Maybe what happens here, need to actually find the traversing mechanism from the find method that we had. So first of all, I think we should always have an if head. I'm going to copy the whole find method. Sometimes we can do that because in this case we know that removing and finding an element is a little bit alike. The only difference is that when you're finding an element, you keep it in the list, but when you're removing an element, you also have to first find it and then remove it from the list. So we just have one more step, makes it a little bit more difficult, but not that much in the end. Let's create some brackets here. And in case we have the value as a head, we need to, as we had done before, current head equals head, and we need to return it, and the head equals to the head dot next. So this is what we had done before, and we had the first two tests passing. So let's now go into a different case. The current node is the head, so we're moving until we find the value. Yep, we have done that before in the find method. Once we find that the next value is the one we're looking for, we basically need to assign in the current node next value to be the next of the next. Make sense? So maybe we need to create a new value, node to remove, which is the one that we have found, like the value is the same, so we need it to be removed, and maybe return it. Node to remove. All right, beautiful. But what we also need to do is we need to get the next value. We need to get the current node dot next value to be the current node dot next dot next. Right now, basically bypassing the node we are about to remove, and then after that we keep going. If we don't find the value here, obviously we're going to keep traversing the list until we find it, and if we never find it, we're going to return null. Let's try to run that test again, the failing test. And look at that, we have a test passing. We have actually successfully removed an element, and we know that we have covered every case. Or should we basically have to check? Because let's see the coverage. Maybe we're missing something. Maybe we're missing some percentage of the lines. So let's go into the Kotlin algos. We find that it's 96. Yes, we're actually missing something. And I actually can understand what's going on. Because if you think about it, we never have to traverse this while loop a lot. Here it is, the uncovered line. You can see with the red indicator that Android Studio gives us. So let's try to maybe help it a little bit, make it have 4 nodes instead of 3, so that we can actually test the traversal. And we're what basically going to do is we're going to remove one, but instead of removing one, we're going to remove element number in the third position, which is element number 2. But now we have to be a little bit careful here because we're removing 2. So what we're basically going to do is we need to test that this is the third element before the removal. Makes sense. We need that. And we also need to have the fourth element. So let's keep the fourth element as the next one. So before removal, fourth element, which is the next of the next of the next of the next. So we're going 1, 2, 3 after head. So this is the fourth element, and we need to check that the fourth element is the one we're going to find if we simply go next and we go next one more time. So this is the test that I'm trying to prove that is working, and yes, it does. And since now we traversed a little bit more, basically what I'm expecting is to have 100% line of coverage, and we're going to test the theory here. So let's go. And look at that, this is 100% across the board. We basically covered the whole linked list implementation. And I believe that we can stop at that point. Obviously, we can start to doing many more advanced stuff in this list. This is a basic implementation. We can have a lot more. But if you think about it, we have covered basically the most important operations you can have in a list. We can remove an element, we can add an element, we can prepend an element, we can also locate an element. We can now say that we can understand what happens, and you can take as a homework the idea of adding more methods to that list. I'm basically going to include the whole implementations that we have had until now in the description, so you can clone it, you can basically test yourself, you can actually go crazy with this list, and I'll be more than happy to answer any questions that you may have on the current implementation. So that's it. That's the first algorithm that we have implemented in Kotlin using a test-driven approach. I hope you learned something from this series of videos. And if all goes well, I'm planning on covering more data structures in that test-driven way. So until next time, I'm Konstantinos. Have fun.